Hi friends, thank you for joining in today. Could you please confirm on the chat window if you are able to see my screen here? You should be able to see my whole screen with the chat window on the side and with a Google Sheet or doc where we'll discuss each of the questions. So could you please confirm if you're able to see my screen and hear to my audio? There are a few questions here on the chat window. I'll try to answer some of these as we go. Right, so is it clear? Could you please confirm if you can see my screen and hear my voice? Yeah. So not visible. Is there a problem? Is there a problem, guys? Because some of you are saying not visible, but most of you, at least one of you is saying not visible, but everybody says everything is good. Could you please confirm if my screen is visible and if my audio is audible? Could you please confirm that? Rajesh Tejasvi says all okay. Okay, cool. Again, some of you may have low bandwidth. Just try to okay, all is good. Okay, all is well. All is well. All is well. Yeah, so that's the right thing. From I think 3 Idiots. Okay, cool. Visible and clear. So Rajesh has a good question, which is after watching videos and doing practice questions, should I directly go for test series or should you solve PYQs? Actually, I have solved quite a lot of PYQs in the videos themselves. Once we introduce a concept, we try to solve some of the PYQs. Anything that is missed out, please solve them and then you can go to the test series. Or you can directly go to the test series, taking the topic test and subject tests. Even that is okay. It doesn't matter the specific order of whether you're doing PYQs first or you're doing the test series questions first. Any order is okay. But please first finish the videos, the solved problems, and then all the practice problems that are there, and then go to the test series. And then you can do either test series or previous year questions or vice versa. Any order is okay, right? So don't worry about that. Please increase the pixel quality. I'm already streaming at 1080p if I'm not wrong. So yeah, please increase the pixel quality. Oh, this is from one of our teammates. Okay. So this is, I think, to others who have issues. Please try to increase it. At least I'm streaming at 1080p. No point doing 4K because it just consumes too much bandwidth and most people don't watch it in 4K. So hey, all of us are doing good. Thankfully, the whole team is safe because we have shut down our office in the first week of March as soon as there was the first case in the IT hub of Hyderabad. Thankfully, everybody left the city, went to their respective towns or homes, and most of us, actually all of us are safe. So thankfully, all of it is good. And as I was just mentioning earlier, we have started uploading DLD videos. We have uploaded a few chapters. We'll be uploading roughly 2 hours of video. We have already recorded some of them. We're just post-processing before we put out a chapter or so, right? So what we'll do is, once we finish the whole DLD, we'll also say perfectly all right. The faculty member who taught earlier is a very experienced faculty member. But if you prefer my style of teaching, we have started uploading it already. We'll start uploading roughly about 2 hours of content every day. We've already done a huge chunk of content that we are post-processing, and we'll send an email when everything is done. Okay. Okay, so Rajesh has a question, which is actually for watching 30 minutes of video, it takes about 1 hour 30 minutes for me to grasp the concept. So it is time taking and slow compared to others. Yeah, so actually in the videos, we teach concepts fairly slowly. So if you're taking 1.5 hours to understand a video of 30 minutes, that's slightly on the longer side. I really wanted to understand why is it taking so much time for you, given that we try to go very slow, in a very methodological fashion. So I'm trying to understand why you are taking so much time. Again, we already give you notes, so you don't have to spend time taking notes. My suggestion is watch the video once. After that, read the notes, just highlight all the key points, make short notes parallelly. So you watch a video, you see the notes, you make short notes, that way you'll move very, very fast, right? So is referring textbook for DBMS compulsory? Again, for all of our subjects, if you don't have time, don't refer to a textbook, because we cover everything that is needed for the GATE exam. If you have extra time, certainly textbooks are great, but textbooks are also very vast. They take a lot of time, right? So my suggestion to all of you is, first, please finish all the subjects. If you have time, you can always go back to the textbook at a later point. What we have covered in our videos is more than sufficient for GATE preparation. Again, we try to be very focused based on what is needed for GATE, while a textbook is very exhaustive, right? That's what we recommend. Okay, cool guys, it's already 7:02, so let's get started with the session itself. Okay, so okay, cool. So let's get into the topics itself. So today's topic is again, we'll solve these topics, or we'll cover these topics in in databases. We'll probably do about 3 sessions in databases, one today, the other tomorrow, and the third one next week. So today we'll cover ER diagrams, basics of relational schema, relational algebra, basics of SQL. In the next session, we'll focus a lot on functional dependencies, normalization. Then the third session we'll do transaction and concurrency control, indexing, file structures, etc. This is the rough marks. DBMS, you can easily expect 7 to 8 marks on an average. Again, this is data from the previous years. There are some papers where you might get 5 marks. There might be some papers where you get 10 marks also. But on an average, you can expect about 7 to 8 marks. And just from these topics, you can expect about 4 to 5 marks. And typically, DBMS questions are either easy, very easy, or moderate. You don't encounter hard problems typically in databases based on the last almost 10 years worth of data, right? So please understand that. Okay, so let's get started. We have about 9 questions for today's session. So let's go one by one. Okay, here starts the first question. Let's dive into it. I hope it is clear and visible. Again, in databases, typically questions could be lengthy. So please be patient in reading them, but they're easy. Again, for every question, we try to give this level of hardness. We don't go into hard problems because this is the first iteration that we are solving these subjects. We typically give easy or medium in the first iteration, but as we come closer to the exam, we'll move to medium and hard. This is medium based on GATE standard. That's important. This easy, medium, hard is based on GATE standard. Again, this is a very standard type of question that you can expect in GATE with asking you the number of relations or the minimum number of relations required given a ER model. Again, in our course videos, we have solved tons of problems explaining you how to think about problems like these, because this is a very common problem pattern that you will encounter in GATE. Okay, some of you are saying 5, 4, 6. Just think about it. Think a little. It's a slightly tricky question. That's why it's medium. It's a very common question in which you can make mistakes. Again, for questions like this, please draw the ER diagram on a piece of paper. Okay, some of you have put in your answers, but just please reconsider and think about it a little more. Again, this is a very common problem pattern where a lot of people also make mistakes. So just think about it carefully. Think about all the entities, all the relations, all the attributes, and how many relations you might need. Again, some of you obviously got it right, but many of you have got it wrong. It's slightly tricky, so you have to think about it carefully. Okay, so since we have many more questions to cover, let's go into it, right? So, okay, so let's go into this whole problem, right? So consider an entity relationship model with three entities E1, E2, E3. Okay, so let me just draw E1. You have E2, and you have, let's say, E3. Right, so you have three entities. E1 has attributes A and B. A is primary key, so let's write attribute A, which is primary key. Then you have attribute B, which is not primary. Okay, entity E1 has a many-to-many self-referential relationships R1. Right, so you have a self-referential relationship R1, which is from entity 1 to entity 1 itself, right? So it's a self-referential relationship. It's called let's call it R1, and it's also many to many, right? So this is one aspect. First, let's draw the whole diagram. Then we'll look at how many relations we need. Entity 2 has three attributes. C is the primary key. Cool. C is the primary key. There is D. Very importantly, there is E, which is multi-valued, right? So one way to represent multi-valued is double circle. Right, so like a person can have multiple phone numbers. That's what multi-valued basically means. Further, entity E2 and E3 are related by one-to-many relationship with E3 on the many side. Okay, so you have, let me draw it properly. So you have a relation R3 here. This is one-to-many, right? So E3 is on the many side. Yeah, so this is one, this is many. Okay, and entity E3 has two attributes, G, which is primary, right, and it also has H. Okay, cool. What else is given? Attribute F is a relationship attribute of R3. So there is a relationship attribute called F, right? So I think, okay, is there anything that is missing? One second. One second. So entity E1 has a many, okay, and entity E2, oh sorry, there is entity E2 that is having a many-to-many relationship R2. Okay, so there is also R2 here. Okay, so there is relation R2 which is many-to-many with E2 is having with E1. Okay, so there is this many-to-many relationship also. Right, so this is your ER diagram, right? So now let's look at the tuples that the relations that we need, right? Let's assume we have. I'll start numbering it. So let's assume we'll start small and we'll keep increasing as we need it, right? So let's assume we have one relation to store E1, right? One relation to store E1, because there is a self-referential relation here. We need one table or one relation to store entity 1. It's A and B attributes. Because R1 is a self-referential relationship, we need one more table for this or one more relation for this. Cool. Then look at this. This is a many-to-many, right? So if you think about it, it's a many-to-many. So because this is many-to-many, you can't add E2 to E1's table, right? So what we'll do here is let's create another table for E2, right? Now this is a many-to-many relationship. So you'll create one more table here. Again, I'm trying to go a little fast here without going into the nitty-gritty details as I've explained in the course videos, because otherwise we'll not be able to solve 9 problems here. Okay. So I'm going slightly faster in explaining the answer. I'm assuming that you know these foundations. Otherwise it will be hard for me to finish it in this span of time. So then we have, okay, the important part here is E is a multi-valued attribute, and you have entity 2 which has C as primary key, but this is multi-valued attribute. So you will have to create one more table to store these multi-valued attributes. So that will be table 5, right? Now if you notice, you have entity 3 with G as the primary key, and its participation is many to 1 in E3. So you can combine these two. You can combine these two into one table, right? Remember, this will be the primary key, right? You can combine, because this is a many to 1 relationship. You can combine this whole relation and entity into one single table. So now you need like what? 6 tables, not 5, right? Many people miss this fact that this is a multi-valued attribute and it needs a table of its own, right? So if you draw the ER diagram and if you follow the basic principles of how to evaluate the minimum number of relations, you get 6 as the answer, right? Again, it's very, very easy to make mistakes. This is slightly lengthy because you have to read through all of it. You have to draw the diagram and think through carefully, but it's an easy problem. Okay. The reason we tagged it medium is because there are so many places where you can make silly mistakes here, right? So that's the reason. Cool. So let's go to the next question now. Okay, so let's go to the next question. Yeah. Again, this is an easy question, but slightly tricky. Again, here, remember that this is total participation. We're talking about participation, total participation and partial participation here, right? Okay, so let's tackle this question. Again, for those of you who have forgotten this double line basically means total participation. Okay, again, there are no attributes here, so you can assume if there are any primary keys. Just make that rough assumption. Oh, it's already 7:15 and we've only solved one question. Let's see. These questions can be slightly time taking from databases. Again, as soon as a bunch of students answer, I'll dive into the solution itself. Again, because of time constraints, I may not be able to explain each of the concepts here, because we assume that before people come here, they already know the concepts. That's the whole purpose of practice, right? Again, if you're a course enrolled student, you can always, anything that you're not sure, we have covered this with tons of examples and previous year questions in the course videos in lot more detail. This is an easy question. If you're careful, it's fairly easy. Some of you have started answering it. Again, here please make sure you take the total participation and the partial participation into consideration. This is all about participations. Okay, people are answering 2, 3, 4, 5, all the 4 options. So yeah, so this is double lined. So this is double lined, this is double lined, this is double lined, double lined, double lined, single lined. Okay, if you're not sure of it. If this is slightly harder to see, this is what it is. So again, this is a straightforward problem if you know about the participations concept. First, let's start going step by step, right? So you have a customer table, you have a customer entity, car entity, and this is total participation, right? Because this is total participation, you can always combine these two into a single relation, right? You can always combine them into a single relation using this, and you can create something called as a composite primary key, right? You can create a composite primary key, which is the primary key of customer and primary key of car. Again, we have not shown the attributes here, but you can use that, create composite primary key and create one relation or one table just for this, right? Now, the next thing that you should be aware of is you also have a total participation here, which means if you have created one relation that contains customer and car entity and their attributes, you can also loop in policy information, because this is also a total participation from both sides. So you can just have one table or one relation which can take care of the customer car policy. One table or one relation can take care of this and this relations and all these three entities because of total participation from both sides. Right? So one entity is, one relation is taken care of it. Now here, if you notice, look at this. This is partial participation. This is full participation or total participation. In this case, since both of them are not total participations, you need a second table or a second relation for this, for accident and the participated relation. Right? So the minimum number of relations you need in this case is 2. And many of you got it right, which is very good. Right? So it's 2, that's important. Again, some of you are getting confused between many to many and, see, if it's not, look at this, if you have not used arrow marks, again, you should always look at whether there is an arrow mark like this or not. This arrow mark basically means many to one, right? If the line is just single line, it means partial participation. If it is double line, it means total participation. That's the standard syntax of writing ER diagrams, right? So unless and until something is shown using arrows or using double lines, just assume the default, right? So that's important. Cool. So the answer here is 2. Okay. Again, this is a simple problem if you know about how to handle total participations and partial participations. Okay. So let's go to the next question. This is slightly lengthy, so I have to put it in a smaller font. Please try to read it. It's a very simple, easy question. Again, this is also an easy question by GATE standard, but a very good question. Yes, in the previous question, the participated relation and accident are merged into one relation. Yes. So since I may not be able to answer all the questions that are there in the chat window, primarily because I also have to keep a track of the flow of questions. If some of our mentors are online, could you please answer some of the questions? Because I don't want to go back to a previous question once we started the next question. If any of our mentors or team is online right now, I'm not sure who is online now, but if somebody is online, could you please answer some of the earlier questions, please? Yeah, this is a very simple question. Yeah, if you know referential integrity, this is a straightforward question. And if you know on delete cascade, of course. Okay, so most of you got it right. So let's go into it. It's a very straightforward, easy question, typically asked for 1 mark. It takes time to read the question, but it is super duper easy. So what are we deleting here? We are deleting this tuple with S203. Where is S203? So we are deleting this tuple. When we delete this tuple, let's see, S203, we delete this also, right? So when you delete S203 because of on delete cascade, right? So you delete S203. So wherever S203 is, you have to delete that row also, right? Obviously, since S203 is a foreign key here, this row also gets deleted, right? Simple, right? Now S201 is deleted. So let's look at where is S201. S201 is here. So because it is on delete cascade, this will also go away, and S201, this will also go away. All right. So again here, okay, so that's it. I think now everything is cool. So now let's see, on deleting this, the set of tuples that must be deleted to maintain referential integrity is 1, 2, 3. Yeah. So all these have to be removed. So the answer is 2. Very straightforward. If you know the concept of what is referential integrity and what is on delete cascade, this is trivial, right? That's why it's an easy problem. But similar problems have been asked in the past in GATE, right? Okay, so let's go to the next question. This is also an easy question, very easy question. Yeah, so some of our mentors are trying to answer students' questions. Good. Good. Okay, again, because this is the first iteration of databases, we are giving easy and medium questions, but we'll do multiple iterations of every subject. Hopefully, as we come closer to the examination, we would have finished, we would have done a lot of medium and hard questions also. Again, this is a fairly easy question by GATE standard. Most DB questions are lengthy, but easy, or sometimes just about medium. Sometimes, like this question is very easy. Okay, since most of you got it right, so let's go into the solution itself. So what does this say? This says x such that x belongs to P, right? So intersection x belongs to Q. So this is very similar to 3. Most of you got it right? So one second. Sorry. My bad. So I drew the arrow wrong. Sorry. So 1 to 2, right? So this is like intersection. Like this is like logical and, right? So this and this, which is nothing but this intersection this. So that obviously eliminates start eliminating options fast. Okay, so this is eliminated, so you're left with option 2 and 4. Let's look at the second one, which is cross product, right? Cross product, you can write it as from P comma Q, or you can also write it as select star from P comma Q. Both of them are syntactically correct. So 2 should map to 4. Cool. But in case you are doubtful, look at the third one here, right? What would the third one map to? Third one, basically it's a projection operation, right? You're selecting columns A and B from P, right? So 3 should map to 1. So this is straightforward. This is actually a trivial question. Sometimes you could be asked a question like this for just 1 mark. Okay, very simple, straightforward question. Okay, let's go to the next question. Okay, I hope, yeah, the whole question is in the screen. This is medium because it's slightly tricky. Let me just edit it slightly. I think it's better to say what is the maximum total number of tuples What is the maximum number of tuples? I think that's a better way of framing this question to avoid any uncertainty. Again, please read the question carefully. Again, the reason it is medium is because it's very easy to make a mistake here. Please take your time. Actually, I can do one thing. Actually, I don't have to say maximum. I can just say what is the total number of tuples the resulting relation can contain after the alter statement. Even that is the right framing. Yeah, I don't have to say maximum there or minimum. I can just say what is the total number of tuples. Okay, broadly all of you are saying either 7 is the answer or 20 is the answer. All of you are tied between those two options. So think why it has to be 7 or why it can't be 7, why it has to be 20 or it can't be 20. Think about it from that perspective. Again, this framing is slightly, just let's go with the flow. Yeah, option 10, option 3 and 4 are meaningless, right? So it has to be either 7 or 20, right? Mostly, that makes logical sense. But which of them makes more sense given this question? Okay, so I think a lot of students are tussling between option 1 and option 2. So again, I think to avoid any confusion, it's better to, let's look at the question itself, right? So you have a create table, you have employee ID, last name, first name. Of course, employee ID is not null, salary, manager ID, and the manager ID has to be unique. And employee ID is also primary key, which means it has to be by default unique, and it's not null, right? Remember that for manager ID, it never says not null. So it could be null. That's important, right? It could be null. That's a very, very important thing that you have to be careful about, right? So the total number of tuples inserted in the above query are 20 with employee IDs ranging from 1 to 20. So employee ID 1 to 20, they have inserted. They have already inserted 20 rows or information about 20 employees. They've already inserted it. Then they run this alter table. Right? So you actually have 20 employees with employee IDs integers ranging from 1 to 20. So 20 are already inserted here. That's what this statement says. Then this alter table statement is executed. What does this alter table statement say? This alter table says manager ID has to be greater than equal to 2 and less than equal to 8. Right? That's what it says. That's what this check says. Right? And it says unique manager ID But manager ID, it doesn't say anywhere that it need not, so it doesn't say that it's not null, so it can be null. Remember that uniques, basically, if you have a column which is unique, it can contain nulls. That's a very, very important aspect. That's a tricky part here. So if you have a unique column or a unique attribute, it can contain nulls. It can actually, right? And the fact that manager ID int not null is not there, which means manager ID can be null. So we have, let's assume we have a table where we've inserted 20 employees data, right? Even if there are some managers whose manager ID is less than 1 or greater than 8, or less than 2 or greater than 8, right? If those manager IDs are made null, everything else will still be satisfied, right? So again, you can keep the 20 employee IDs information that you have put in this table. You can keep all of the 20. Remember, you can keep all of the 20. You don't have to delete any of the tuples by just making the manager ID, wherever the manager ID is less than 2 or wherever the manager ID is greater than 8, just make it null, right? Because unique attributes can be null. That's a very important property of unique, right? And here it doesn't say that it should not be null. So it can be null. If it is null, remember that if it's null, this check won't even matter, right? So the right answer here is 20, right? So the solution is very simple. When you do this, the simple thing that will happen here is manager IDs which are less than 2 or greater than 8 will just become nulls and you're done, right? So 20 is the right answer here. It's a slightly tricky question. The key aspect here that you have to realize here is manager ID can be null and uniques can be null, right? So that's very, very important. Okay, cool. Okay, so let's go to the next question. Okay, so this is the 6th question. So please, Manish, remember that null is treated in a very special way by SQL, right? So you have to understand how null is treated in SQL itself. Okay, null doesn't mean the concept of null in our colloquial, the way we use it. Null is treated very, very specifically in SQL, and that's what is the key here. This is a question about SQL, right? So let's go to the 6th question. Again, please read this SQL queries very, very carefully. Most of SQL is easy if you are careful with it, but it's so easy to make mistakes. Always read all the 4 options given to you. Please don't read just 1 or 2 options and tick them. It's a very common silly mistake that people commit. Please read all the 4 options given to you. Again, it's a very common silly mistake not to read all the 4 options given to you. So, okay, some of you got the answers, but some of you messed it up. Common silly mistakes. So, let me explain it. So, you're saying customer ID is int, not null. Customer name is varchar 5, not null, which means it has to be a string of length no more than 5. Address no more than 10. It can be null. Contact ID is integer. The primary key is customer ID. So, primary keys always have to be unique, right? So, let's look at the first statement. Insert into customer values 1, Shivangi, Agra, so and so, right? So, obviously Agra fits into 10 characters, but Shivangi doesn't fit into 5 characters. So, this will create an error. So, many of you might just jump and say, hey, 1 is the right answer, but you have not read through the rest of the options. Certainly, 1 will be ignored by the SQL server, surely. But let's read 2 now. Insert ignore into customer these values. Now, if you notice here, Amit fits, Delhi fits, Ram fits, Mumbai fits. Oh, Mumbai is address, right? Yeah, Mumbai fits because it has 10 characters. But if you notice, this is 2 and you have the same 2. Primary key has to be unique. So, this will also be ignored. Now, there are 2 options. So, here you have option 4 which says both 1 and 2 will be ignored. Now, let's look at 3. Always look at all the 4 options to be double sure. This is perfect, this is perfect, perfect, perfect. So, this will be inserted successfully. 1 and 2 will not be inserted, which means option 4 is the right option. Right? That's the important part. Again, some of you may have just read through these options and said, hey, 1 is not being inserted, so 1 is the right answer. You have not read through the other options. That's a very, very common silly mistake, please. Right? So, that's very, very important. Okay, cool. So, let's go to the next question. Again, this is also a very simple, easy question. Again, some of you have a question about insert ignore. I'll just tell you after this question is done. Yeah, I think one of our mentors already put in the answer. Yes. Yeah, thanks folks. Yeah. So that's the answer for insert ignore. Again, some of the questions that I cannot answer because we have moved to the next question or we are solving something else. Our mentors would put an answer to that in the comment section for you guys to follow through. Okay, so most of you have answered this question. So let's go into it. It's a fairly simple question, right? So select customer name from customer where referred by is not equals to 2. right? So obviously this will not be returned, this row will not be returned, right? Certainly. The question is all about nulls, right? Remember that null is not equals to 2, right? That's important. So this will be returned by the query. So null is not equals to 2. So because you want referenced by not equals to 2, it will return the first row, it will return this 4th row, it will return 5th row and 6th row. So it will return 4 rows. Again, null has a very special significance in whole of SQL. It's very important to understand how null behaves in various circumstances. For example, here the question is all about not equals to, right? So null is not equals to 2, so it will return this. 2 is equal to 2, so it won't return this. 2 is not equals to 2, so it will return it. Null is not equals to true, so it will return it. 1 not equals to true, so it will return, so on and so forth. Again, null has a very specific significance in SQL with respect to the operator that you are using it in. That's very important. Okay, cool. Yeah, Rajesh, that's true. Mentors try to provide the best. I think we provide the best mentorship and we strive to always improve ourselves, both in these live sessions, even for our course enrolled students. Again, the amount of effort they put in is enormous. Cool. So let's go to the next question. This is all about regular expressions. Okay, so this is about SQL and regular expressions. Again, this is also an easy question if you know about regular expressions in like command in SQL, and if you know escape. Again, please be careful because this is very easy to make a silly mistake on. Many of you are forgetting this escape keyword. Okay, some of you are putting in the answer, some of you are putting in 1, some of you are putting in 2, some of you are putting in 3. Some of you have started putting in 4 now. Okay, so let me tackle it for you, right? So you all know about like, right? So whatever you give in like is used as a you have to think about from a regular expression standpoint, right? So underscore in whatever is there here, underscore basically means single character, right? And typically percentage means 0 or more characters, right? So that's the typical syntax of regular expressions in like. But here we have this escape. When you say escape exclamation mark, we want to use exclamation mark as an escape key. You all know about escape keys in any major programming language or anything, right? So escape keys basically means that will be ignored. So let's see. First you start with G, cool. Then percentage. Percentage basically means 0 or more repetitions of it. Then you have exclamation mark followed by underscore, which means whatever comes, this is now used as an escape character, right? So underscore will come as underscore itself. So you'll have G followed by some characters followed by underscore. So gate underscore will fit into this into this pattern now, right? That's important. So gate, so this can't be the answer, this can't be the answer. It has to be 3 or 4. Similarly, you have A, okay, then you have A, you have percentage. Percentage basically means 0 or more repetitions. Then you have exclamation underscore. So exclamation is used as an escape character now, which means you can have 0 or more repetitions followed by an underscore. So applied will fit now here, right? Next, look at this. This is where we have made it slightly on the trickier side. C, you have C, exclamation, percentage, right? So exclamation basically means you can have quotes here, right? But whatever comes after this percentage will be printed as percentage itself. Okay, so the tricky part between 3 and 4 is that 4 is the right answer because you have the percentage after exclamation. Here you have percentage before exclamation, right? So that's the important part. So this exclamation will match this exclamation because it has the escape key before that, right? That's the idea here, right? So it's an easy question if you know about the regular expressions concepts in like. Again, if you don't know about escape, it's okay. It makes logical sense. You know about escape characters, right? So even those of you who didn't know, it's very easy to recognize that this is the escape key that you want to apply. That's the whole idea, right? So cool. I think there is a small typo here. This C should be a lowercase c. Thank you. Yes. Yes, I'm sorry. Yeah, this C should have been a lowercase c instead of a capital C. You're right. That's a mistake. Yes. Okay, cool. Sounds good. So let's go to the 9th question. This is a slightly lengthier question. And again, by the way, we have covered these concepts in our course videos also. For those of you who are asking that question, I think one of our mentors also mentioned that. Okay, cool. Let's go to the 4th question. Let's go to the last question now. This is just about nested queries, so please be careful. These are the questions where people make most mistakes. Again, there are options 1, 2, 3 and 4, so please read all of them. Again, please be very careful in reading what is here. Again, nested queries are the trickier ones, so we have to be careful there. Okay, I think people are all over the place. 1, 2, 4. Think about it slightly carefully. You will get it. Again, nested queries can be fairly tricky if you are not careful. This is a very standard type of nested query that is typically asked in GATE. I've seen very similar problems in the solved problems and PYQs multiple times when I was recording those videos. Okay, so let me tackle it anyway. So let me try to explain this as best as I can. So find the names of sailors with a higher rating than all sailors with age less than 21. Right, so let's look at the first query. So select s1.name from sailors s1 where not exists. So it should not belong to whatever is returned in this set. Right, that's important, right? So where not exists basically means it doesn't belong to the set here, right? Okay, so select star from sailors s2 where age is less than 21. Cool. So we are selecting all the sailors whose age is less than 21 and s1's rating is less than equal to s2. So what this is doing literally, again, you have to think of nested queries as a nested for loops. I mean, that's one way of imagining this if you're careful with it, right? So if you think about it, what does it say? It says, I don't want sailors. Look at this. I don't want sailors because it says not exists. Okay. Or in other words, I want sailors who do not belong to this set. Now, what is this set saying? This set is saying, pick up S2 as sailors whose age is less than 21 and S1.rating is less than equal to rating, which means now what will happen here? We will pick up sailors whose rating is strictly greater than S2.rating and S2's age is strictly less than 21. So this is actually meeting the requirement that we have here. This what is it doing? Think of the way, again, for the same query there could be multiple ways of writing nested queries. For the same task, different people can write different nested queries. So what we are saying here is we want those sailors, and we are calling it with an alias S1, who do not belong to this set. And what is this set? This set consists of, this set basically says that if S1's rating is less than or even equal to S2.rating, we don't want such an S1 here. And what is S2 here? S2's age is less than 21. So what will this result in? It will result in all the sailors S1 or the names of sailors who have a rating that is strictly greater than all the sailors whose age is less than 21. And that's what this is saying. So 1 is certainly the right answer. But if you notice the options, it could be both 1 and 2. Obviously, this can't be the answer. So we have to look at 2 also and be carefully think about option 2 also. Let's look at option 2. It says, select star from sailors S1 where S1's rating is greater than any. Okay, what is there in any? Okay, so what does this say? This says that, look at this. This also returns a set if you think about it, right? So this also returns a set now, right? This returns a set where S2's age is less than 21, right? It returns all the ratings from sailors whose age is less than 21. But you have an any here, not all. What you have here is any, which means if S1's rating is more than even one sailor whose age is less than 21, right? Even if S1's rating is more than even one such sailor, it will result. But that's not what we want. We want the names of sailors with higher rating than all sailors, not one sailor. So this certainly is not the answer. So 3 also cannot be the answer. So 1 is the right answer. Again, you have to think very structurally on how things are working, right? So again, this can be very, very tricky. I understand that it's a huge cause of confusion for students. But even after this session, just think about what's happening here. Again, this less than equal to can be confusing, but what we have used here is not exists, and this is a way to trick you. Okay, actually this is the easier nested query. Okay, this one is a slightly trickier nested query because you're using a not exists here and you're using less than. That's what makes this little trickier. Okay, so in general, 1 will return what you want, 2 will not, hence 1 is the right option here. Okay, I hope that is clear. Okay, so yeah, so those were the questions. Yeah, we almost completed in the 1 hour. Thankfully, after many days, we completed in just about 1 hour. I'll pack it up in 2 to 3 minutes. So again, please understand that what we have done today is mostly easy and a few medium questions, because this is the first iteration of databases. In the next iterations, as we progress closer to the exam, we will focus a lot on medium and certainly a few hard questions, right? So going forward, we'll focus 70% on medium and 30% on slightly harder questions, right? A hard question is nothing but a medium question with some trickiness. Again, unfortunately, we may not be able to answer all the questions. As one of our mentors rightly pointed out, anything that you think is incorrect here or anything that you're not sure of, please drop us an email and we'll try to answer as many questions as we can. Okay, in a tight session of 60 minutes with about 9 to 10 questions, it's hard to answer. In a public live session, it's very hard to answer all of this, right? So please understand that. Again, our objective here is to expose you to a wide spectrum of interesting problems so that you can practice it. Any explanation that you're not convinced with, feel free to email us and we'll help you with it, right? So sounds good. Thank you, folks. Thank you very much. And see you tomorrow. Again, tomorrow we have another session, right? Where we'll discuss, if I'm not wrong, let me go up. So tomorrow we'll discuss about functional dependencies and normalization. That's the topic of discussion tomorrow. Again, there are many other types of problems in relational algebra, SQL, ER diagrams, etc. We'll cover them in the next iterations. Okay. Thank you very much. Thank you, folks. Bye-bye.